In this second section of Chapter 11, Section 11.2, we'll talk more about angles, central angles specifically, and also about the arcs. Remember, we learned about arcs in Section 11.1. So a central angle we've talked about in a previous chapter. A central angle is an angle that has its vertex at the center of the circle, and then the sides of the angle are radii of the circle. So over here, this angle, A to C to B, that would be a central angle. Recall from this previous section that we just covered that a minor arc is an arc that has measure less than half of a circle, so less than 180 degrees. It's always named with two letters. So AB, arc AB, that's the symbol for an arc right there, is a minor arc. A major arc, on the other hand, is always bigger than half of a circle. So it's bigger than 180 degrees. So the arc that goes from A through D all the way to B, that would be a major arc. And they're always named with three letters. And then finally, the last type of arc that we learned about in the previous section was a semicircle. Remember, a semicircle is exactly half of a circle. In degrees, that would be 180 degrees, and it's also named with three letters. So major arcs and semicircles are named with three letters. Minor arcs are named with two letters, all of which have to have the arc symbol over the top. Arc measures. Arc measures are in degrees, just as angles are in degrees. And in fact, an arc measure is always equal to the central angle measure. So if you look over here, they tell us the measure of arc AB, right here, would be 50 degrees, because the central angle that goes with it is 50 degrees. That means that the major arc from A through D to B would be the remainder of the entire circle. A full circle is 360 degrees, so if we subtract the 50 degrees for our minor arc, we get 310 degrees for that major arc. So the measure of an arc is always equal to the measure of its central angle. Let's take a look at a few examples here. Arc RS. Arc RS would be this one that I've highlighted in yellow. It has to be equal to its central angle. So the measure of arc RS would be 110 degrees. That would make it a minor arc because it's less than 180. The arc that goes from R through T to S, from R through T to S, that arc is more than 180. So that's a major arc. In fact, it's the remainder of the whole circle. So a full circle is 360. If we subtract the 110, we find out the measure of arc RTS would be equal to 250 degrees. And finally, arc RST. Now, once again, the arc RTS was a major arc. Arc RTS, well, if we look at it, RT is a diameter. So the arc RST would be a semicircle. So that means the measure of arc RST will be exactly 180 degrees because it's a semicircle, half of a circle. The arc addition postulate. The arc addition postulate says we can add the measure of two adjacent arcs together to get the measure of the entire arc that's formed by the two arcs combined. If you look at the diagram, in the diagram, they've asked us to find the arc AC. So the measure from here all the way around to there. That would be 29 degrees plus 108 degrees. And 29 plus 108 gives us 137 degrees. The arc from A through C to D. A through C to D. That would start here and go all the way over to there. Well, I have to add 3 arcs together for that. 29 plus 108 plus 83. The 29 plus 108 we already know is 137, plus 83 more, I get 220 degrees. If we were to classify those arcs, this first one would be a minor arc. Notice it was named with 2 letters. The second one is larger than 180. It would be a major arc. Notice it was named with 3 letters. When we put the M in front, we're referring to the measure of the arc. So we're not naming the arc, we're looking for the number of degrees. We have a couple more here to do. The arc from A through D to C. Now, it specifies we have to start at A, then we have to go through D, and then we have to go, oh, my mistake. If we start at A and we go through D to C, we have to go this direction. So in that direction, I would have to add 79 plus 61 plus 83 because I'm going from A through D to C. 79 plus 61 plus 83, 223 degrees. Another major arc. The last one that they've asked for in this particular section, they've asked us to go from E through B to D. E through B to D would start here and go in this direction. Well, we could add all of those together, but when I look at that, E through B to D is really the entire circle except that green 61 degrees. So it might be more efficient to just take 360 minus 61. And if I take 360 minus 61, I get 299. And that should be the same we would get if we added up all the other ones together. The 79 plus the 29 plus the 108 plus the 83. And it is in fact the same. That's called the arc addition postulate, similar to the angle addition postulate and the segment addition postulate we had in first semester. We're supposed to identify these arcs as major arcs, minor arcs, or semicircles and find their measure. The arc that goes from T to Q, from T to Q. Well, the central angle is 120, so the measure of the arc from T to Q would be 120 degrees, which would make it a minor arc. The arc from Q through R to T, Q through R to T, well, that's really the whole circle except the 120, so I could just take 360 minus 120, and I find out the measure of our QRT would be 240. That would make it a major arc. And finally, the last one that was asked for in this particular section was the arc T to Q to R. Well, I can see that that has a diameter once again going through there. So that's going to be a semicircle. And since it's a semicircle, I know the measure of it, TQR, arc, is 180 degrees exactly. And that's because I recognized we had a diameter going through there, TR being a diameter of the circle. Next, we're going to talk about congruent circles. Well, congruent circles obviously means it's the same size. They have the same radii or the same radius. But congruent arcs, they have to have two things the same. They have to be in circles of the same size, and they have to have the same number of degrees. So to be congruent arcs, there must be two conditions. In circles of the same size, and they have to be the same number of degrees. They have to have the same central angle. So when you look here in number 4, example 4, these two red arcs, they are congruent arcs. They're in the same circle, and both are 80 degrees. However, in B, these are not congruent arcs. And it's because the circles are not the same size. The last one, these once again are congruent arcs. And the reason is the circles are the same size. They have congruent radii, and arcs have the same number of degrees. Because they have the same central angles. So congruent arcs must be in circles that are the same size, and they must have the same number of degrees. Well, in this problem, we're asked to solve for the measure of minor arc I to H. The problem is they didn't give us enough information. However, we can determine what x is, and once we have x, we can substitute it back in. I can see that I have a diameter right here. Since that's a diameter, I know the arc JHG is a semicircle, which means 180 degrees. So if I was to add the 6 plus 11x to the 22x minus 1 to the 43, altogether they would have to equal 180 degrees. Combining like terms, we have 33x and then 6 plus 43 minus 1 is 48. And if I subtract 48 from both sides, I have 33x equals 132. Divide by 33. So x is 4. The measure of arc IH would equal, let's see, IH would be this one right here. So I'm going to use this 22x minus 1. 22 times 4 minus 1. So the measure of arc IH would be 87 degrees. And again, measures of arcs are in degrees. So we began by noticing we had a diameter, which meant we had a semicircle there, semicircle being 180. Then I knew I could use the arc addition postulate to set up my equation. Number 6. Well, in number 6, we're to solve for x. And I know that the measure of the arc will be the same as the measure of the central angle. So I can set up an equation, 3x plus 9 equals 113. And then I can subtract 9 on both sides. And 3x would be equal to 104. And I divide by 3. X equals 104 over 3. This does not reduce. Now I hope that made sense. Remember that the measure of an arc is equal to the measure of its central angle. That's what we learned new here. We can use the arc addition postulate to add consecutive arcs together to get an entire arc. And don't forget, minor arcs are less than 180. Exactly 180 is a semicircle, and more than 180 is called a